Hey, welcome YouTube. So in today's awesome and exciting video, what we're going to be talking about are free body diagrams. Free body diagrams. Now, free body diagrams, abbreviated FBDs, are diagrams that represent all the forces applied to an object. Okay, and the reason why we want to do this is because we want to calculate our net force. This is the total force applied to an object. Okay, so I'm going to give you some common examples. Okay, so in example 1, we've got a ball that is dropped. A ball that is dropped. Okay, there is, assuming no air resistance, which is what we're going to be doing in this course, typically, meaning no friction. What that implies, guys, is that the ball itself only has one force applied to it. Can anyone guess what that is? Yes, that's right. It is gravity. And this is the abbreviation for gravity. Okay? So it's Fg, where the G obviously stands for gravity. This is also called the weight of an object, which we've talked about in a previous video. So a free body diagram typically has a dot, so this is the FBD, a dot along with the vector, whereas this is a typical diagram in general of the actual system. It's a ball that is being dropped. Okay, so after it is dropped, this is the free body diagram of the object. Let's do another example, shall we? So let's go on to a next page, a new page, and we'll talk about another example. So here we go. It's full screen. Let's say I am let's say I'm in an elevator, okay, and I'm standing in this elevator, and the elevator is not moving. So the velocity of the elevator, VE, is 0. Okay, what are the forces applied to me? What are the forces? Well, the forces applied to me are twofold. I've got gravity, but the elevator itself is applying a force up onto me to balance the gravitational force. We call this force the contact force or the normal force, abbreviated F normal. This force, as I mentioned just now, is a contact force. It is the force applied by any surface perpendicular to the surface itself. So it's the contact force. Awesome. Now, when an object has constant velocity, we will see later on, this means all forces are balanced. And if all forces are balanced, guys, what that means is the sum, so this means the sum of all the force vectors, and by sum I just mean addition, so the sum of all force vectors equals 0. Okay, so for example, the arrow going up perfectly balances the arrow going down. What I'd say then is that Fg plus F normal is actually 0. This is not always the case. You will have situations where the net force, okay, this is the net force, you will have situations where the net force is not always 0. For now, in this video, we will only talk about cases where, or at least as pertaining to this video, we're only talking about cases where the net force is 0. In the next video, what we're going to be talking about is Newton's second law. And in Newton's second law, we will definitely see cases where F net is not 0. Okay, so we'll see that in the next video. Thank you for watching. Don't forget to like and subscribe, and I'll see you in the next one. Peace out, guys.